When you have an equation with x and y's in it and you're trying to graph it, sometimes you have to find the x and y intercept in order to do this. So if we have a line, say right here, we want to know the x and y intercept. The x-intercept is where it crosses the x-axis, and the y is where it crosses the y. So that's where it crosses the y, that's where it crosses the x. So for the x-intercept right here, the one thing we know for sure, in every case, the y coordinate is going to equal 0, because it has to cross that axis. Similarly, for the y-intercept, no matter what the line, we know that x will equal 0 at that point. So using this information, we can then say if we have this equation, 7x minus 3y equals 42. If we want to find the x-intercept, we know the y equals 0, so we can plug in 0 for y. And then it becomes a one variable equation that we know how to solve. So 7x, 3 times 0 is 0, equals 42. Seven x equals 42, and then we can divide 7 from both sides. Know that x equals 6. So after that, we can then, that's our x-intercept. Now if we want to find our y-intercept from this equation, we know that x has to equal 0, so we can plug in 0 for x, and now we can solve that also. So you have to remember to keep that minus, even though 0 doesn't amount to anything. So we have negative 3y equals 42. So the y-intercept, after we divide negative 3, would be 14, negative 14. So for our original equation here, also written here, we know that the x-intercept is 6, the y-intercept is negative 14. So the reason that that information is so helpful is because if we look at our graph again, we know that x-intercept is 6, so crosses the x-axis at 6. We're going to count by 2's here, so. And we know our y-intercept is negative 14. And then we can find our line.